Good evening to one and all present here. This is my privilege to introduce our speaker of the today's session. He is going to handle the session on design and testing of hydrogen powered vehicles. So the speaker for today's last, it is the last session of this our FTP, is Mr. Venkatesh. He did his masters in automobile engineering from MIT. He has a total experience of 16 years in automotive domain, vehicle R&D. His expertise in vehicle electronic control, service diagnostics, system engineering and calibration. He did a lot of projects in this automotive domain. He handled regional business for southern region in automotive organization in vehicle application engineering, electric powertrain design and development. Then his award, he has received a lot of awards and honors. He is guiding many projects for the students of MIT and other premier institutes. He has total 2 patents, international patents and 9 domestic patents, all in the vehicle electronic control and hybrid vehicles. These few words I request the speaker, Mr. Venkatesh, to hand over, to take over.
Okay. I will take another 1 to 1.5 hours to explain on hydrogen and specific to engine and vehicle. This will be my 1.5 hour session. I will also try to tell the research gap, and I also try to touch upon a little bit where the machine learning can be implemented to overcome the development. So this is on it. As Mr. PDJ sir has hinted, this is my profile. I think he has given a very brief overview of it. And I'm trying to say something which I'm doing it as, like, say, budding topic in last 2 years. And this is not known too much, the technique what I'm telling to outside world. I'm happy to share what we are trying to do, and the materials which is available outside world or in the textbooks are also very limited. So this is the way I have consolidated my contents. Okay, to start with, today we speak about having a passenger car with electric vehicle as a trend, and you can also see some level of gasoline and diesel engines also there. And in future, probably closer to a smaller vehicles will have fuel cell, and there is a limitations of fuel cell which we will detailedly discuss in another 1 hour. We can do that. And alternate it can be with diesel and fuel cell probably. Higher size vehicles like say buses, government aims something called HCNG. I'll also give a overview on it. And on addition to this, the like say ethanol blended diesel and fuel cell is also on the focus. This is all on future. And the higher tonnage vehicle, as of now today, there is no clarity. I'll also give something called H2 ICE, which is internal combustion engine, will be the mainstream for future, and we will dwell more into it and how the technology or the research activity is going on. Yeah, this is on it. And in turn, probably you might have heard about hydrogen synthesis and electrolysis and many things from the other speakers in the past. I will also slightly touch upon that. Okay, so as I hinted, today I'm going to explain to the level of hydrogen basics and what it can do on chemical properties. And since I'm from automobile development, I'm trying to touch upon the application of engines and automobile vehicles to that area, and some research area what we are trying to do. And it's never ends there. Anything you do a research or you do a product, it should fulfill the legislation. I'll try to hint about the legislations what is available for this particular thing to realize. And while explaining this, I will also explain about the control system what is required to make this particular technology to get realized. So this control system can be of electronics, or it can be combustion, or it can be the learning models what we have for combustion optimization. It can be even the limitations what is coming to hydrogen to realize these controls and the safety requirements of it. Yeah, so this will be my clear focus area. And since hydrogen is like something which we know, but vehicles may not be too much. I'll try to touch upon the economical impact, syncing something to what we know is electric vehicles and limitations comparison I will touch upon. So my session is 90 minutes, but I will try to limit bit early and we can have a question answer sessions to have an interactive way. So I will start something with what is the challenges today have in a fuel, okay, and what as a Indian government they are trying to do for fuel to be self-reliant. So this I will be touching upon. After that, it's not like something which is for self-reliant. I'll also tell what is the investments happening across the globe and what is the technology upon it. So after the fuel is there, we will go back and say what is H2 as a fuel and what is it can do for us in our day-to-day automobile. This I will touch upon. We'll go deep into conversions, limitations, factors influencing all the stuff. As I hinted, once it is done, legislations or regulations are strict for hydrogen because of safety. I will quickly go on and then let's have a Q&A session. Yeah. So this is how it's been planned for 90 minutes. So going to very basics, we all know we being India, we only import the fuels today. Let it be a diesel or a gasoline or any kind of contents other than recent years compressed natural gases. Mostly it is all imported, and we get import from Middle East mostly, majority of it, and also a little bit from Russia and USA. And I think this is a 2023 figure. Now the numbers are changed, but nothing great has changed on this. We are always only importing and majority of us import. On the other side, we know very well this emission is killing from day one, and from Delhi there is always a pressure we hear, but it's not only Delhi, across India we have a problem with this. So two problems now. One is we are importing oil, other side we are getting more emissions, and that is where we are pitching in for some alternates, for example electric vehicles. So now let's think about electric vehicle. So electric vehicle needs, so we spoke about fuel where it is not coming from India, and we also have emissions, and we spoke about EV, and even there the mining or a raw material, if you see the statistical number which is coming from 2021, it's mostly predominant somewhere batteries are coming from China, we very well know, and raw materials nowhere. Let it be a raw material or a processing or a batteries or cells. This is not though where India is there in the picture even today. Yeah, it's even in 2024 almost the statistical remains same. So are we speaking about EV as a future? Then where is India on EV? Yeah, so this is again a big question mark, and we are not very great in that even on EV. So we can build EV and we can tell it is eco-friendly, and we can tell we have better range is happening, and we have a lot of vehicles launching. But for India or sustainable for India, are this particular technology is going to help? It's going to be a big question mark. Of course, yes, other aspect EV has a better advantage, but not from the materials availability or to say that what is content coming from our country. Yeah. So and little bit we know like from EVs there is also some pitching in happening for a fuel cell. Yeah. So we will also detail discuss into fuel cell, and their fuel cell also we have a battery which is also one of the main component, and it requires hydrogen to run this particular vehicle, which is not there predominantly or not available in commercial in India for automobile. And we also have the fuel stack, which is mostly the rare materials again, and 100% it is not coming from India. So when we try to move from say EV to hydrogen fuel cell, which is more green, we can tell, but again, are we there in India on a raw material? It's again a big question mark. And when we can able to develop the technology for fuel stack or the raw material for fuel stack is also a big question. So let us summarize what we spoke. We have IC engine running on, which is internal combustion engine with the diesel and petrol. Other side we have EV, and let us discuss on say 5 aspects. One is raw material, economic growth, which is economic growth as I'm saying for India, and the vehicle cost what we purchase, and also the total cost of ownership. For example, if I'm going to run 5 years, where are we? And as a development or a research activity, do we know this technology to develop it? Yeah, so we will see in that portion of it. And whether it's eco-friendly, because we are also speaking about pollution and air quality concerns in India. Yeah. So starting from raw material, as I hinted, we don't have most of components, basically the battery segment of it. Of course, the chassis, materials, tire, tubes, we have it, but the main raw material of EV, which is ores, which we don't have it. But if you say 100% of ICE engine components, we have it in India. Let it be starting from smaller component to bigger component, or let it be calling from, say, metal pieces to the chip portion of it. We have it in India. Then economic growth, whether if I keep importing, as the economy is going to help. Maybe earlier I brought it from Middle East for ICE engine. Maybe tomorrow I'll get it from New Zealand or China. So this is what it's going to be there. Probably we will do small assembly portion of it, but it is not green yet. Then coming to vehicle cost, today we are adjusted to the cost of say engines, but EV is slightly costly. Probably down the lane it may come back to a comparable price, but this is a long question again, as I hinted in the start, whether we have a raw material to reduce the product cost. Yeah. Then as a research, we know we are experts and we have done a lot of researches and we have a lot of technology in India to make engines, and we keep developing on this portion. EV has a limited technology. Probably it takes some more another decade to have our own technologies and our own understanding of EV, but it's improving. But EV has eco-friendly because it's not going to give emission. This is a claim assuming that we are using a renewable energy for generating electricity, but still majority yes. But we know ICE engine, whatever we go, we are going to pollute the environment. Let it be BS5 or a BS6, whatever you call it, we are keep polluting it. Yeah. So again, where we spoke, battery materials are not there, but this data says where it is. Yeah. So slightly of manganese we have, probably to some extent. If in future we come back with aluminum batteries, we may have it. But the core materials what today we have required for a battery, it is not in India. Yeah. So it is probably getting from different portion of the globe. So this is where we have concern even in future for a EV. So we are, if you see as a EV battery imports, India ranks top in importing, followed by Vietnam and US, which means that we are again top importers in the world for a battery. Yeah. And other than this, we also have a lot of shipments which is coming from various part of globe to meet our today's electric vehicle requirements. On a lighter note, we might have seen now slightly we are also moving from two-wheeler to car till passenger car on a CNG. This getting in pockets of maps. CNG is pulling it up, and latest one is this particular two-wheeler. So it's a good sign, but the question is, are we having CNG as a replacement for diesel? I think this is take a long way, and we have also constraint in doing it. But yes, CNG is one which is budding on. Okay, so now we spoke about the challenges of fuel. We spoke EV is good, but what is the concern with the EV? We spoke about it, and we also told what future, if you want to make it better way, what is it? So now let's say, if what is India looking at for self-reliant on the fuels? Yeah. So we know we cannot become a Middle East country to get a more of oil. We cannot change it. So our government under scheme, they are trying to say that, okay, India, let us try which fuel we can able to do on our own. So this particular Ministry of New and Renewable Energy, yeah. So this MNRE departments continuously work on it. Whether can we do something towards that? Yeah. So they started a mission, and they also have a vision for it, and there is a clear target which they set it, and there is a micro level of activity which they are planning. For example, they have to start producing green hydrogen somewhere a reasonable number from 2030, and also there is a plan how to generate it. We'll look more into it, and there is also very clear technology which they are trying to aim to meet this particular requirement. Of course, it's not only the government, it is also the alliance or the configuration which is coming from the other parties. Yeah. So this particular scheme is an inspiration which starts, but this seems to be a kind of thing which government is banking on for future. The reason behind is they have a strong solid base to say, if not we have diesel or gasoline or diesel or petrol for future, if EV comes, how to handle it for economy purpose. If not EV, we cannot able to do best for our economy. What is next? Then this particular is green hydrogen mission. Okay, so first to start with, government, as I told, they are working on, it's not like they are working alone, and they are also trying to explore a lot. So one among that is particular MNRE has issued us for 2025-26 a 496 crore as a pilot project. This is 100% only to do research, which means that what you can do with hydrogen for our automobiles. So this is the target. So nothing else other than that. So particular cost is given to, let it be a education institute or industry. Anyone can claim it. Only thing is, what is the research you are going to do? If it is promising, you will get the fund. So this is the sowing seed from the government side, which says that I will give money, please do a research. Yeah, so you can go and browse through this particular MNRE page. This is still almost in the frozen level, but this particular funds are getting analyzed or distributed, but still this project is on. Okay, so this is on other side. The private players, they also trying to set up the plans. For example, in Tamil Nadu, there is another one plant which already has been foundation laid on. So this particular plant is going to generate hydrogen. Yeah, so this is not for future. It is already stone is laid, and they are trying to aim in another 2 years. Other than that, government is also trying to pull up our steel plants, and also I will touch upon there are hill stations which is available in India. They already started producing it. So, but the quantity is low, but the production has already started from the government side, which is the initiation from government. So, two portions: a private player which is trying to get it government approval and make it as a bigger plant, and coming also from the government which has started. So, but this doesn't end too much, and we know the impact what the Reliance and Adani groups are trying to make it in India. So, coming from Reliance, Reliance has started a series of development R&D centers. They focus two things. One is production of gases. Second, especially the green hydrogen gases. Second one is developing the vehicles so that it can run in green hydrogen. So this has started from Reliance, and this already they started producing set of vehicles in collaboration with other companies. And there is Reliance is also signing up with the global players who are masters in the hydrogen production, where electrolysis is one of the key technology where we can get hydrogen. They already signed up for it, and they also have lined up with other parties to have a technology brought in, but it will be produced in India. So left side there is a production plant, and right side there is a technology now which Reliance is planning on it. Okay, so now we are going to produce, we are going to do it, and fuels has stabilized to say, for example, like say closer to 100 rupees for both diesel and petrol. The promise, what the basic understanding of this process and the investment shows is Reliance is promising that they can give probably per kg of hydrogen at $1. So $1 probably it's less than 100 rupees. So this is something which we can say it's like say as a kg if you compare, it's cheaper or it is very reliable for future. And this is going to be 100% in India. It is not going to get imported as today. Yeah. So this is the promising content which Reliance has started contributing. And as I hinted that this is only one portion of it. So Reliance has invested huge, and they have technology tie-up, and they also promising the government that they can come give a hydrogen at this cost. So other side, as I hinted, the other big players in Indian market is Adani groups. They also have the same plants. They also have promised that they will also be able to do hydrogen generation in India. So this is one case. And addition to this, since Adani has also a lot of other businesses, they will be trying to use the natural gas plant, which already they are masters in it, to generate hydrogen. So basically here, hydrogen as a gas can be taken from various areas. So green hydrogen we speak, and there's other side we are speaking about hydrogen coming from natural gas. So various technologies are possible. We'll also understand what does it really mean for production. But this is a second player which has a promising entry, and now these two are one of the top businessmen who work on gas and fuels for India. So this is where we see like this particular supply is going to kick off, and we will have a self-reliant India. Okay, so now coming to hydrogen, we know this is hydrogen is like say H2. So basically we are taking it from electrolysis process, as simple as that. Say 2H2O with some energy, we can split into 2H2 and O2 and our area of interest is H2. So this is a basic chemistry which everybody is trying to work on, and this is almost the same technology which they want to, Reliance want to procure from the European countries. The reason behind is the efficiency. So they need a mass production and a high volume content coming from this particular electrolysis process. So the technology type is getting happen on the background. Okay, so what is the aim now? So for example, we can say like we get this renewable energy because for electrolysis process we need energy. So Reliance is planning to set up yards of areas where they can able to generate current from electricity from say solar and wind, and the electrolysis process can able to do this job, but it needs energy. As I told, this particular tricky process where it will get a profitable hydrogen generation, this is coming from Norway for Reliance as of now. So hydrogen will be produced, and this can be transported to any part of India in the trucks. Yeah, so this is the area which they are working on, and probably this particular hydrogen can be used in various means for automobile. Yeah. And key to notice, we know that hydrogen combustion can happen, and we have oxygen enormous in the ambient. So end product is going to be water and electricity. So end of the day, we are going to have, say, in a fuel cell, it can be electricity, or it can be power, and we are going to use it for hydrogen engines. So the output is not going to be anything other than water. Okay, so now coming to hydrogen, as I told, we are trying to explore it, and it is one of the potential to replace our today oil and gas requirement, or mostly about the import. And we already use hydrogen. We know very well. All our rockets are powered by cryogenics, and this particular concepts is there for as a concept is there for the rockets or for the space requirement. So we are not new to it. Probably we are trying to migrate, or we are trying to use a similar site modification for automobile. And coming to the properties is very important. Reason behind is this particular hydrogen is a lighter one and colorless and odorless. Why I'm hinting it is, say we have something like say hydrogen used for our vehicles. We are going to use it for our day-to-day use. This particular colorless and odorless gas should be handled with care. And if it is a lighter gas and it's more lighter, which means that this particular gas is going to be very lighter compared to say other gases, especially what we use it today for automobile, and this is going to have issue when some leakage is going to happen. Yeah, so this is one caution point. I will touch upon this later. So now question is, if I want to use it as hydrogen vehicles, there are two options I can do. Yeah, one is I can use as a fuel cell, hydrogen powered fuel cell, or I can use it for hydrogen powered internal combustion engines. Yeah, so this technology in principle both are possible, but the question is which particular technology is going to help also for future sustainable from the raw material point of view, or from the economy point of view, or a scalability point of view. Yeah, so this both are competing now for future, and government has done some evaluation. We'll also touch upon that. Yeah, so before going to what is the benefit out of it, probably you might have heard this from other speakers as well in the past. I'll try to touch upon quickly. Yeah, so fuel cell is that we need hydrogen and oxygen. There is a fuel cell which is a stack which is available with a lot of catalyst inside. If we pass on to this particular fuel cell, then what we get is electricity, which can be used to run the motor, and as I hinted, the output will be water. So this particular electricity will be used, like say, then after electricity comes in the vehicle, it will be like a EV. So now difference is, what is different between EV, electric vehicle, and fuel cell is, we will be in electric vehicle will charge the battery. Here we'll have comparatively a smaller battery, will fill the hydrogen gas. So on the go, if you keep filling hydrogen gas, this particular onboard generation of electricity will happen. So that's why I hinted this particular technology uses hydrogen probably in future, which is supplied from or manufactured or produced from India. But again, some limited quantity of EV is also inbuilt into the fuel cell. But of course, when hydrogen is available and we have a better minerals for battery, probably this is one of the best for future. Okay, so it doesn't end there. Complexity of fuel cell also goes slightly high. For example, I have hydrogen which can be from India, then it goes to a fuel cell where electricity generation happens, which I hinted. Today we don't have a technology, or we don't have materials to produce it, which more about going as again as an import, but this can help in generating the electricity. Other than this particular electricity will be converted to a DC-DC, or it can be converted to AC based on the motor principle what we are going to use it, and there will also be a battery to store it. So basically, the generation goes to battery, electricity generation from the battery, the motors used to power the vehicle. So when the battery gets or drops the voltage, or we don't have energy in the battery, again the hydrogen gas is used to produce the car. That's why I hinted this particular vehicle is half a kind of hydrogen vehicle, we can say, but the other half is purely like operating as an electric vehicle. So in some countries there is all the products available on a initial level, not on a mass production but on an initial level, but mostly the Western countries are going towards this direction, and they see this as one of the promising content for eco-friendly vehicles. Yeah, so EV we keep charging it, but here we keep filling hydrogen and it acts as a EV. So it's a hybrid of hydrogen and the electric vehicle. So the West is more focused on it, and here you see Toyota product is one of the proven product which is commercially also available today. The technology demonstration plus the practical end user application where it can be sold to the general public. But of course, as I hinted, this is only a initial level of vehicle development and initial level of product, but it's on a limited scale, which is one of the promising. So what about India now? If we are able to get this to India, probably when we have hydrogen, it's just a matter of having a better environment control, but also better utilization of the fuel for it, which is hydrogen. Okay, I will not go deep into it, but I will quickly hint what this particular technology mean. Okay, so we have two things here. As I hinted, the basic chemistry is we need hydrogen and oxygen. Then the fuel cell will convert this into electricity. So the layout looks slightly probably complex, but I will put it in a simpler way. So the green color is a fuel, which is the hydrogen tank here, and what you see white from this side is the air. So air and fuel gets in. So we need some more for this particular synthesis. We also need some air. So we'll have bigger size of turbocharger like what we have today, and this both contents goes as a, like say the fuel cell what you see here. The whatever I'm highlighting here is a fuel cell, or we can say it's a fuel cell stack. This particular fuel cell stack is going to take both hydrogen and air together, and it's going to generate the electricity. Yeah, so it also needs a level of control there. So we'll have a microcontroller or the onboard computer to regulate all this process. Yeah, so it's a, like say today we have engine control unit, in future we'll have a fuel cell control unit which will be regulating it, and other sensors and required to monitor it's always there. Yeah, so this particular fuel cell is going to generate the current, and this particular current what is generated can be used for the electrical vehicles or the motors which is there in the fuel cell vehicle to run them. So this is how the layout looks. I will repeat. We have two portion of fuel cell. One is the green color one is hydrogen, and the blue one is air. Both get mixed, compressed, and there is a regulated, and it goes to portion D, which is called fuel stack. It's more about the rare materials and the catalyst what is there in the fuel stack. This particular guy will generate the current, and this particular current will be used for driving the vehicle. Okay, so it doesn't end there. There is also other products which is there in the market or in the development which can able to realize it. If you see here, this particular vehicle, they are trying to place a tank on the bottom side of the chassis, and the onboard generation, the fuel cell is kept on the front of the bonnet of the vehicle. So where here the electricity gets generated, later this electricity generated is sent to the wheel motors where to propel the vehicle. So such things are already there, as I hinted, on a development and also few models on the production. So similar thing is also on process to think about this particular bigger vehicles. See, now today we can tell EV is there for future, but do we have such a bigger batteries to accommodate, or such a bigger vehicles can be powered by electric vehicles? Yeah, so this is kind of a big question mark today is there. So we will see why particular bigger vehicles we have concerns. But today there is also development going on. It's not in kind of production, but there is a development and research going on. Say that to use a fuel cell for a bigger power vehicles. Probably this will be a 400 or to 300 to 400 HP vehicles. So how to power up such a massive vehicles and run it? If not EV, then what else? Then the question is fuel cell electric vehicles. Yeah. So as every product has both the side plus and minus of it. So hydrogen fuel cell advantage is like it's renewable. As I told, it's clean green and we can charge it fast, which means that gas can be filled in 10 to 15 minutes. But you know how long a EV vehicle takes. I have a experience where the commercial vehicle or a bus which is running from Chennai to Bangalore, one of the EV bus, it's only one company which runs it. They need at least 30 to 45 minutes in the middle, closer to half the way to charge the vehicles, which means that they cannot operate AC, they cannot run the vehicle. For sure, they have to take a break for charging the vehicles. So in this fuel cell will not have such a issue because gas filling probably will take 5-10 minutes, fill it and you can continue. And no visible pollution because the output of the combustion is water. So very clear there is no pollution coming in that aspect of carbon. Other side, the negative portion of it is the raw material. As I told, it uses mostly platinum and iridium. Both these guys are costly in India, we know very well, and it is not available in India. So which is very clear, this is going to be a bottleneck for us. This need a huge investments and investment with respect to technology, because we don't have such technologies or development majority happening in here. We have to develop somewhere from other countries on the investment front of the technology. And storage, this is a concern because this also still now not a mature level. Hydrogen is very flammable and we need a regulatory or a regulation coming from the government how to use this. So this all still like say in the initial pipeline. This has a long way to go, but still there are a lot of advantage in it, and the development is going on towards this. Probably after 5 to 8 years you can see some changes in this area. Okay, so now we spoke what is EV advantage to diesel comparison we did. Now we are speaking about our government is thinking about using hydrogen fuel as a fuel for the fuel cell vehicles. Okay, so now where do we lie this comparing to EV? So EV we spoke, we don't have too much raw material. Probably the similar case also for fuel cell. Probably we have hydrogen here, so it's not as worst of EV. Yeah, we have some raw material for generation. Economic growth, both the cases is same. Slightly advantage in fuel cell is like probably will not import too many raw materials because hydrogen we have it, but still it is not green. The technology is not in India. At least EV we have little bit, and we have sharing from other countries. Fuel cell, even in the other countries or a developed nation, they are still on a development phase. So the product is going to be very costly, and this is going to be kind of a topic whether fuel cell is good for environment, good for Europe and other developed nation, whether it's for India. So this is going to be a big question for us. Technology clearly red, we don't know, we don't have it. We have to develop this technology in India. The fuel stack or the assembly, this is going to be a future engine. This has to be explored. And the one big advantage, or the only big advantage in both the cases, this both are eco-friendly. We can say it is like say CO2 neutral, and we are not going to get any CO2 out of it. Yeah, so probably compared to diesel vehicle, EV is best, but EV has a migration to fuel cell, because as I hinted, fuel cell is half hydrogen and half EV. So this both the guys also have its own limitations. Okay, so this is how the investments or the fuel focus is going on from India. So we will tell, okay, I'm not sure how many knows what happened or why we speak hydrogen, or I'm not sure whether we know really India is progressing towards hydrogen. A quick roadmap. So why does this evolution happens? It's as simple. We are importing fuel. Government wants to work on it, and also we are killer of emissions and air quality. So this is again a push which is coming from carbon neutrality. So with this, government has worked for electric vehicles and also CNG and fuel cell. And once this particular idea is will speaking about the fuel cell is a replacement for EV, the private players or the businessmen in India, they told that they will be able to reduce the dependency of fuel imports. So they started investing in the business because this is one of the big boosts for Indian government in addition to hydrogen generation. Yeah. So today we know Reliance portion of fuel is very low compared to government, which they are trying from Middle East and trying to refine and sell it in the market. So here we did see that the private players will also have a better advantage or a better volume compared to what government can do. So this is one thing. So now world is thinking about, or at least India is thinking, if I want to be self-reliant, it should be a vehicle. It should be HCNG or H2S. Yeah. We'll quickly look into what is HCNG and H2S. So this is where it is. The reason is like, say, for example, we have fuel cell here, hydrogen is there, it doesn't end. Reason behind is engine. As I hinted, we know what is engine and we are self-reliant in engine. So anything you use again engine and not pollute the environment, I think this will be the best solution which government thinks. Yeah. So we are speaking about producing fuel in India, which is in this case, we are speaking about hydrogen. So now we have to understand, like say we have petrol, diesel, kerosene, CNG, LNG. Hydrogen also has a varieties. So we call it as gray hydrogen, blue, green, turquoise now, kind of blue again, and a brown hydrogen. So basically what does it mean is this particular colors comes from the way how hydrogen is produced. If you are going to produce hydrogen from methane, it's going to be called as gray. If we are going to produce it from kind of say carbon capture technology CCS, then we are going to call this as a blue hydrogen. As we hinted, if we are going to use a electrolysis, which the current is coming from say wind or renewable energy, and we use electrolysis process from water, then it's going to be a green hydrogen. And as I hinted, this is only a renewable or a best mode of hydrogen required, but we cannot expect too much output of green hydrogen. Reason behind is the efficiency of electrolysis, what is there. Yeah. So green hydrogen is good, but scalability or a mass production point of view, we have to think about. And methane and ethane are all there in India. So the question is like, from the methane plant, from there can we extract hydrogen? So there where the turquoise comes into picture. And our coal production, whatever we have today for electricity generation, you can use that also for electrolysis and keep producing hydrogen. If I'm going to produce it, then we are going to call it as brown hydrogen. So probably in future we may have different colors of hydrogen selling it in the market. We have to wait and watch. But government is more focused on having a share of green hydrogen compared to others. Yeah. So as I hinted, at least in India, practicality is three. One is green, because we have water, we can have electricity, and we can able to extract better from electrolysis. Blue hydrogen is possible because now India is having kind of a natural gas sufficient to some extent. This can be used for hydrogen. So blue is also seems to be an alternate for it. And natural gas is there, and there is a plan to increase this particular share. Probably in future, since we export, say for example, one from Iran, one from Dubai, and one from probably Russia. In future, we may have a different kind of plants which will be supplying for hydrogen. So today, what is it? Government is not clear because technology is still evolving. Probably it takes another 5 years to understand which is the best for future. Yeah. So but if we say like we need a green hydrogen, we need a kind of say megawatt plant of solar photovoltaics, because we know we are in the geographical location where we get better temperatures and lights. So this was one of the main area which green hydrogen can go further. And electrolysis is a simple process from water, so we can depend on this as one of the main source for hydrogen. Yeah. And if it is green, green hydrogen, we can call it as a renewable energy. So we are not going to pollute too much. But if the other hydrogen comes, we have to see the way what is going to pollute. But like today, we need, say for example, say green hydrogen can meet only 50% of need. Probably other share we have to go to gray or brown if we want to reduce our yeah. So this is a key message. But which will click? This is a big question, as I hinted, it has to progress. But whether we have only green hydrogen for future, as I hinted, technically there will be a limitations in getting mass demand of hydrogen requirement. Probably green hydrogen will have a bigger share, but not 100%. So this is a key message for future. Okay, so today we have, it's not like we are only speaking about fuel cell or electric vehicle or aerospace for hydrogen. Hydrogen is also today used for other areas like marine, heating unit, food processing, chemical productions, and also, as I told, rocket launches, everything this is there available. So then, which means that we are not starting from zero, but we are not having 100% capability to meet hydrogen requirement for future. So natural gas. As I hinted earlier, Adani groups are trying to focus too much on it because they are there, and Reliance is also have this particular technology available. So they want to use particularly natural gas for hydrogen. So this is one of the way forward which is there. And there is also plans from government that they want to go by solar and tidal power. So these two are their plan, and there is a plant in Leh which is in production of hydrogen from 2023. Last 1 year they are producing hydrogen, and this plant is also supplying hydrogen for vehicles which is running in that area. Yeah. Okay. So now hydrogen will be produced. So this infrastructure has to be sent to every, say today we have a fuel stations, there should be hydrogen gas station. So this has to happen, and this infrastructure is not yet developed, but this is getting developing. But only limitation here is particularly this particular, say for example, if I'm going to fill 30 kg of hydrogen, so there is a story saying that in Delhi, if I'm going to fill 30 kg of hydrogen, you can able to fill in 10 to 12 minutes of refilling time, and this is sufficient to cover a per day running of city buses. Yeah. So this is the promising content which is there, but very important as we have to see is the hydrogens are stored in carbon fiber tank. We'll also understand why in the future. So, and there is also a density which is coming to problem on storage. But yeah, this is one of the key message which is going to be there. Yeah. Okay. So whatever we are saying are most of things what I told is 2030 on a mass production. Yeah. So but it doesn't end there, and government doesn't simply have a ambitious target of 2030. Yeah, reason behind this, before studying this, there is already a tie-up, as I told, Reliance has already done with the government, and Reliance has huge invested on this area. So they are planning to convert 500 diesel truck which is running in Reliance in Jamnagar in across India. Predominantly they want to convert into hydrogen power truck, and this particular power truck which is there at the bottom. Yeah, so this particular truck is from Leyland, but Reliance took this project and they are converting this to a hydrogen project. So basically, hydrogen will be produced by Reliance. That is a key idea, and they want to try it out in their production plant first. And Reliance, you know, they are not the vehicle manufacturers. They will be supplying this particular hydrogen to across the India, and all the vehicle OEMs will be using it. So here in this case, they gave a demo with the Leyland, and I'm happy that this particular vehicle, even I am part of a development, I have driven this vehicle. So there are closer to say double-digit numbers of vehicle which is already running in Jamnagar successfully, which means that hydrogen production is possible, vehicle can run, and already vehicle is running in Reliance plants. Yeah. So first target is BS3 and BS4 vehicles. They have to remove and do a retrofitment because they are polluting huge. So this is the first target. And once we say like we have a retrofitment ready, then probably we'll go with like say BS6 category of vehicles where 100% it will be hydrogen power. So this is no more a nightmare or a technology what I speak, which is will come in the future. This particular vehicle you can see is particularly, it's already developed, and the test runs are going on. A good number of vehicles are running in the yeah. So this is a pilot project we can say from India, and it's a first pilot project. The other guys are also following. Like say Tata is also working on, and you can see other companies also has hugely invested and they are working on. Okay, so now it's target for government is like use the engines and do a retrofitment. So there will be a tank, a blue or a green hydrogen which will be there, and this going to power up the engines, and this going to be the retrofitment or a future technology for a vehicle. So, but question is, how much it will be, like say, popular or great. As I hold, this is 2021 data. Electrolysis process gives only 4% of requirement of hydrogen, which means that the other source of generation is a predominant here. So, but if the generation or the hydrogen electrolysis process is going to be a bigger hit, I think in another 5 years we will have technology, we will have raw material, we'll also have fuel from India. Okay, so now we spoke about a truck which Reliance has used. We'll slightly go deep into it, how this particular hydrogen is used in today's vehicle. Yeah, so hydrogen will be used as a fuel for combustion engine, and this particular combustion is going to give some emission thermal, and this particular thermal will be used for powering up the vehicle. Yeah, so this is the basics out of it. So Reliance is taking this particular basic as a core and they are working on. So hydrogen will be coming from Reliance plant. Combustion of engine, this will be say Leyland engine. They will try to do a engineering out of it, and the engine will be modified for hydrogen requirement, and this thermal energy will be used for running the trucks, and emissions here in this case will be water. So literally, if you touch upon the pipe and see, there will be droplets coming out of the bigger trucks as the byproduct. So there will not be no carbon, no smoke, nothing. It will be only water. Yeah. So this is a basic thing which they work, and they consider this will be the CO2 neutral or a green trend for India, especially for the bigger vehicles. So I'm saying bigger vehicles in the say like buses and trucks. This is one will be the one, not one technology, will be more about a only technology which can power in future because of the EV vehicle limitations in the bigger vehicles. Yeah. So we are now speaking about engines, combustion engines. Then we have to get into combustions and also the mechanical portion behind it. So stoichiometric ratio of hydrogen is one of the key factor which will play a role in running the vehicle. There's no doubt hydrogen will, but this is slightly different from it. And the world is also trying to see how to use it. Now we have port fuel injections and direct injections. Both has its own limitations, but both can help in using hydrogen as a fuel for the vehicle. Yeah. So on a stopgap, as I hinted, electrolysis for India, it's very less today. Today we know like whatever fuel we are using it, there is a ethanol blend which they are trying to already use it, which means that our diesel or gasoline or diesel or the petrols are already blended with some other fuels or other alternate fuels. So this is a practice. In the similar way, government is thinking, if I cannot make 100% hydrogen, let me make HCNG, which is kind of hydrogen we can tell, or we can tell it as it's a hydrogen plus CNG put together. So they will have, like say, it's a mix of hydrogen, mix of CNG. Both will be powering up the vehicle till we get a pure green hydrogen alone. So CNG, we know it is getting produced in India to some extent, and hydrogen production has started. This both is one of the promising, and at least they say that a short-term goal and long-term goal. If you have this two, government sees short-term goal for hydrogen will be not only hydrogen, it will be hydrogen plus CNG. Long-term goal will be pure hydrogen. So blending is in progress, or the thinking process go in that direction. Once we start with some initial level of production of hydrogen, we will start running the vehicles with HCNG, which is CNG plus hydrogen. Yeah. So as I told, this is not new. Today we already have E5, E20 fuel, which is there in our fuel station, which is ethanol blended to our existing fuel. So this has started the similar way. Hydrogen along with CNG will be the short-term goal. Okay, so we spoke about investments and we spoke about some technology. Let us go into hydrogen on a research point of view, how this particular hydrogen can be helping in our development, do a better research, how can we be self-sufficient in making hydrogen engines. Yeah. So before going there, let us understand what is hydrogen. Let's compare with the other fuels what we are using. For example, CNG, gasoline, and diesel. Yeah. So hydrogen, you know very well, there is not going to be any carbon content, but other guys have carbon. This is one of the killer in the market where diesel and gasoline are polluting the environment. In the similar way, we can see the energy required to burn the hydrogen is very less compared to other places. But this is more than the point. The more catchy point is the stoichiometric air fuel ratio. So hydrogen can run at 34.5, which means that 3 times what today we are running with, like say, diesel. Hydrogen can produce 3 times more energy, which means that I can get 3 times more mileage. Which means that for running the same distance, if I'm like as I told, $1 per kg, if Reliance is going to give, I'm going to get 3 times better mileage theoretically. Okay, so this is where we can understand why everybody speaks hydrogen. So we are speaking about 5%, 10% fuel efficiency benefit in various technology today. This particular hydrogen, if I power, I'm going to get 3 times better, which means a 300% better efficiency. So if I'm going to get 300% efficiency, now understand why not government will focus on this. Yeah. So this is a green side. Of course, everything has the other side of the coin. You can see this particular hydrogen, it has a lower heating value, which means that like say it can able to burn very fast even with a lighter energy. This is what the meaning of what of it. And second one is the density is very low. What does it mean is probably I need like say bigger tanks to store the same quantity of diesel. And auto ignition temperature is high, which means that knocking and other stuff, we are doing research with the diesel engine and gasoline with various knocking technologies, various combustion strategies. We can see hydrogen is going to have a higher knocking, so which means we should have a better technologies to work on to avoid knocking the engines. Yeah. And flame temperature is very high. A small mistake is going to cause a higher flames coming out of engine or to the public safety. So this is one of the alarming condition if we are going to use hydrogen. Okay, so let's see one. So as I hinted, heating value, hydrogen is having 109 megajoules per kg it can give, which means that I'm going to get 3 times of mileage. So it's not only mileage, I'm going to get zero carbon. So this is the top portion which government sees this is one of the promising for future, and that's the reason both Adani and Ambani groups are investing on this, and this is going to be a better advantage for India and also for the business point of view. So stoichiometric ratio, probably I said today we know it is for diesel it is 14.5 and it is going to be 34, which is 3 times more, which means that I need 3 times more air to burn the fuel. So today market runs with natural aspirated engines. Probably natural aspirated engine cannot be the hydrogen vehicles, which means that I need more air. A turbocharger vehicles is required to power this hydrogen. Of course, we can power this with a bigger turbocharger, but as I told, we are going to get more mileage. So probably the natural aspirated portion will not be huge. Today, the bigger power or higher power engines are all turbochargers. So not going to be a big deal, but put a bigger turbo. Yeah, 3 times a bigger size of today's usage. And the third one is, as I hinted, the minimum ignition energy. So it looks as simple that it needs only lesser energy compared to others to burn. But you may have a problem. This particular fuel gets burnt on its own if you have lighter temperature somewhere in the combustion chamber or hotspot, which means that anywhere somewhere engine is hot, it will burn on its own. I no need to control it. So which is hazard for us. And cooling has to be made very efficient compared to today because of the higher calorific value of the hydrogen. So you can see other fuels are very, very low on this aspect. So this is a unique or a problematic content property of hydrogen, which has to be taken care in the development. Okay, so tank, hydrogen will be produced and every vehicle should have tank because we have to fill it. Only problem is probably I need 10 times bigger tank of today. So you know the size of tank today in a car or a bus, probably if I want the same range, I need 10 times bigger tank. So this basically coming from the density of the fuel, okay, and also the energy content what it has per volume. So you see right side, it's diesel or gasoline lies. In the intermediate, we have CNG, ethanol, methanol. Left side is hydrogen, which means that this is poor in terms of energy content per unit volume, which is basically coming from the density of fuel, and tanks should be very big enough to store it. So I've seen like say there are like say 3 to 4 tanks are put it on the chassis of truck to meet this requirement, because trucks has a lot of space below the chassis. It can be met, but only thing is now fiber reinforced tank or this particular technology will get improvised in future. There's a huge scope in the fiber reinforced materials, and also which can meet the hydrogen storage requirement. This is going to be one of the best, or one of the key research area which has to be focused in India, because we speak about fiber reinforced, but not more focus on hydrogen tank. This has to be focused. Yeah. So we spoke about fuel. Now fuel, we know properties, we know what is the plus and minus of it. Now, how do we do a combustion for this? See, diesel, it operates lean, it has better mileage. Gasoline uses spark plug and it doesn't have too much of emission. Fuel cell runs in hydrogen, no carbon. So where does now in this particular hydrogen powered internal combustion engine, which is H2I, is going to look? Yeah. So this guy is going to have all three. So this is a peculiar new age engineering which is going to happen. This vehicle will have a lean lambda, it will have a spark plug, it will have hydrogen. So which means that you understand the technology is not simple, and it's high level the particular automobile powertrain or engine industry is going to face here, and this work has already started. So it's not we cannot tell this is not a diesel engine, we cannot tell this is not a gasoline engine, it's not a fuel cell, this is a mixture of all three. So now we know that even for a small change of fuel or altering of mixture, we do a lot of research, and we do a lot of materials management or thermal management and engine design. Now this tells us how much is the work which we have to work for making hydrogen as a fuel for IC engine. Yeah, that's a huge work available, and that is the reason where many of them are not working on. But in India, there's a prime focus. So somebody is working or planning for a research. As I hinted, this is a key area where you can see there's a future available, and setting up this particular research will have multiple things to do for next 10-20 years for sure. And also the fiber reinforced tank who was working on materials. Okay, so if it is a mechanical engineer or automobile, key things what to be do it on a research is we have to work on compression ratio. As I told, this is not a diesel. The hydrogen is not going to be a diesel engine. It's not going to be gasoline. It's not going to be a fuel cell, or it's not a EV. It's a mix of all. So the compression ratio has to be matched. We need a better materials which can withstand this particular 3 times higher calorific value. Wall timing and cooling has to be worked on. And from vehicle performance, this will be having a closer match to diesel or CNG performance. And fuel injection, there is a lot to work because the change in the engine is the fuel. So type of injections, timing, studies, probably varying the engine properties, trying to do with this, and that we can do kind of research activity if somebody is interested to take up. And ignition is one key. As I told, the minimum energy required to burn hydrogen is very less, which means that if I put a gasoline or a petrol spark plug, this particular plug is not going to help hydrogen, or it is going to have a adverse effect in combustion. Yeah. So the ignition coils or energy required, though this hydrogen has a spark plug, we may need like say low energy spark plug, as simple as that. Yeah. And engine and exhaust controls, I will touch upon future. And we need bigger lambda, which means that bigger turbocharger, bigger air inlet, and bigger size of air handling engine. So this is the world goes on. If there is an idea of developing some air system expert for engine, you can think about 3 times more air system has to be developed for particular engine. Okay, quickly onto the known technologies, like say port fuel or direct injection engines. If you want to use hydrogen, if you go to port fuel, probably you get like say 28 kilowatt per liter, which means that compared to diesel, I will get low power. So if you want to use a low power, go for port fuel injections. If you want to need a high power, you go for direct injections. But other side, port fuel injections also has advantage and also disadvantage, because as I hinted, coin has both the side. So port fuel, it's easy to develop, easy to control. It's there in India for say closer to 20 plus years technology, but there can be a backfire and we'll have a low charge, which means that I'll get low power. So we have to work on such contents, but this technology is there in India. It can be easily realized, and many are working on this particular technology in a first phase, or the pilot projects, whatever is we are trying to see. This all runs with this particular port fuel type. So long term, DA injections, fuel injection bikes is all recent days happening even for diesel and gasoline. So hydrogen has a better advantage. You need high power trucks, then we have to go for direct injections. If we go for there, then we'll have a better backfire control. You'll have better charge because we are going to inject directly into the engine or a combustion chamber. So charge will be very high, and I can operate at better lambda, which means that I will get better mileage. Yeah, and we know like we can able to control better on the combustion. This is already known in the Indian market. We can do better combustion with pilot, post, and main injections. Coming to after engine, the exhaust. Today, if you see typically a truck, it has a DOC, it has SCR, it has a DPF and other things to handle. Probably in future, if I go to hydrogen, I may not require everything. In fact, because I don't have carbon in the hydrogen, so I don't want SCR and DPF into the picture. Probably I need DOC. Reason behind is if the leakage happens, this particular DOC can help in converting to H2O. So this is not for emission; it's for a safety reason. So future hydrogen vehicles probably will have one DOC for a safety purpose, which will convert hydrogen coming into the DOC to convert to H2O, so that it doesn't go out and becomes like a flammable content. So now let's see where H2O is, stands with EV and fuel cell. We already told EV is better than diesel, and we told fuel cell is also closer to EV. Now at the last we spoke about hydrogen as a fuel for internal combustion engine. Raw material, as I told, we have engines in India. We can make any engines categories. We have fuel coming from hydrogen. It will for sure help economic growth because 0% content can come from outside India. Everything is India. Vehicle cost will be low because we know how to optimize engines, and we already have optimized designs. It's not going to be as costly as battery or as costly as the catalyst like platinum and other stuff. So it's green. Technology research, there is a mix, as I told. The technology is evolving. Probably it's still not green. It takes a long way to go, and it's 100% eco-friendly because hydrogen byproduct after combustion is water. So now I believe this gives a view like why we are speaking or hearing about H2Is and why it will be a future for India. So for Indian aspects, out of 5, we say closer to 4.2 or 4.3 will be the rating for hydrogen compared to other technologies. Yeah. So world is also working on. There is one engine from Dodge which is ready to give 220 kilowatt. You will see a massive engine which we can run in hydrogen. So this is already there, and which says that we are also going in the right direction to catch this. And JCB, we know JCB is all coming from UK. They also have made a like say fuel cell powered engine and also hydrogen combustion engine. Both they have worked on it. What they are thinking is this is going to be a carbon neutral product for them. So that's where they are happy on it, and they also see that this particular will have a better power and torque compared to other technologies. So basically, you know, JCB works on bigger engines, so they feel this technology is still going to help them. So this particular content is also available after Dodge. JCB is also ready. So coming to car, Ferrari has made this as like say one of the promising vehicle for future, basically hydrogen powered combustion engine, and they have also filed a patent last year, which means that even the cars, if in India we decide like, oh, okay, EV or a battery is not going to be a viable or commercial solution for future, Ferrari has started it probably, which is a green signal says that even cars can be future powered by hydrogen. So this particular model is what it's able to do. Only thing is this is slightly like say a bit heavier, they say, compared to others, because we are going to have a bigger tanks. We are going to have slightly high power coming out of it. But okay, when we say from India, I think this should not be a big concern. Yeah. So Ferrari patents are filed for car, and they have a vehicle running with this. This very clear engines can be powered by hydrogen. So quickly, let's see how a hydrogen engine looks. Yeah. So center portion is a hydrogen. So it will have a like say you will have a content where you will have a injections, direct injection, and have a spark plug. So let's see how it works. So green is a hydrogen tank. So we'll have a tank which supplies the green hydrogen, which is marked in green color. And on the other side, air comes from the ambient or atmosphere, which is free. It can be sucked in and sent to the engine. So fuel is green, air has been reached. So combustion is ready once the spark is getting ignited, which is powered by a spark plug. After combustion, it goes to a like say regular route of exhaust gas treatment, and this is how it works. So basically, it has similar, almost if you see the technology, it looks as simple. That's the reason it's getting realized. And I think there is a high explosion category going on. So we are using say a kind of a monitoring system to control whether the combustions are safe and also the engine is safe. We are using a lot of machine learning models here to monitor the engine so that engine doesn't get damaged and this particular gas doesn't harm others. Yeah. So this is how initially the works are going on towards this. So combustion, if somebody is working on combustion, there are 4 topics which maybe in future they can work on. One is engine design, so that it doesn't have a hotspot. If hotspot is there, without spark, the hydrogen will burn because of the initial limits what it has. So backfire and misfire is going to be a big topic compared to diesel or gasoline. So we can work on technologies how to avoid misfire or backfire. And the wall design and wall overlapping, basic engineering has to be reworked because this requires a slightly different wall timing. If I have wall overlap, then gas comes out in the exhaust pipe. So something like that there. And material management has to improve because 3 times calorific value. So we cannot use the same material what we are using it today. So and also the temperature comes out of the 3 times higher calorific value also will be high. So this is a 4th research area which is ongoing and somebody can take it up. So final one, we spoke hydrogen is dangerous. We have to work. It's not easy, combustible, higher flame temperature, 3 times higher energy compared to diesel. So government has started working on legislation out of it. Yeah. So maybe on a lighter note, we know how hydrogen bombs is about. We might have heard of. So if something wrong happens on the combustion, this is going to damage the entire engine. Yeah. So it's as great as the higher flame velocity is going to kill the engine. So there should be a better control on the combustion. So this is the first and the foremost target. And we have a lot of monitoring models what we have developed it, which says that anything going wrong on visual or supervised data which is coming from the engine control unit, this 2 things is going to be the main monitoring point for running the engine. So we will have like say AI and ML models lot in the hydrogen engine, and if somebody has to work on any developing a model, probably this is the right time to work for hydrogen. Yeah. So higher flame velocity, it's going to have a safety concern, and we have to work on the safety point of view. So government has come now draft of automotive standard 195. So this is a standard which is available at free of cost and also free where I will also show a link where it is available. So this particular regulation coming from ARI, Automotive Research Association of India, on this. So basically they emphasize few safety conditions. So this is one of the gist out of the complete legislation. So they are telling that, okay, if anything leaks, you have to take care out of it. So crash, safety, regular leakages or component damage, everything. So on a turn, what we are trying to do nowadays in development is we are trying to put one hydrogen sensor in the tank. If it leaks, it should be able to detect and shut off the valve, and one on the line, and third one on the engine compartment. If any leakages happening because of misfire or valve overlapping or some component damage there, and one for the safety of a passenger. So the 4 sensors is going to take care of safety. So if safety is done, I believe vehicle combustion is ready and technology is ready and fuel is also getting ready. Okay. So we are not speaking about direct implementation or to all the vehicles. As of now, government has realized that genset or off-highway will be the major usage of this. So they have given a legislation mostly for genset and off-highway, how this particular hydrogen should get fulfilled. So this regulations has come from ARI. The primary focus is going on. Idea behind is anyway we have to take a fuel and fill it on the genset. Probably a gas powered tank can help, and safety is not a concern because gensets are not kept closer to humans. Yeah, so that's a key focus. And there are a lot of like say legislations which there is a standards which government has released for profit. So it has a lot of components. Each and every component there is a legislation out of it. Yeah, there's a key message. So if somebody develops a wall, you can think about this particular document, which is you can type in the Google, you'll get this AS 157. It will tell you what is the legislation requirement. If you tell I'm going to develop a tank for this particular vehicle, or I'm going to do a research on it, there's a legislation comes on it, so you can understand what is the requirement. So this is on place, which is available in Google. Is 157. If you type it, you will get these documents. In the similar way, safety side, ARI has given standards for everything, including retrofitment, HCNG, fuel cell if you want to use it, or ICE engine you want to use it. The legislations are available, which means that if anybody develops it, government has a standard. If you fulfill, you can sell it to the public. There's a key message out of it. So standard fulfills. Yes, vehicles are ready to sell, and it will be commercially available. Yeah. So it's not like simple. There is a legislation. Okay, this is says that if I want to have a tank, it comes to my engine. You can see there are 13 components on the way to reach. So this is how the safety has been taken care. Anybody fulfills it, the product is ready. As I told, the vehicle which is running, the Reliance vehicle which I saw, this has 13 components already inbuilt. So the safety is ensured, and in future, if it's ready, I think it can be productionized. So each component there are safety and legislations there. As I told, if you type AS 157, you'll get all those things already available. But the key message is every component has a safety and legislation and legislation rules and regulations available. Please, if you work on it, adhere to that, because if you want to make a powerful product, it doesn't fulfill AS 157, your research or your study or a value proportion is not going to help. Yeah. So we spoke storage. This is how trucks looks. So the vehicles, if you see, there will be tanks on backside of this particular cabin, and there will be all this 10 to 15 components will be running from that particular cylinder, and it will power the engine. Yeah, and let it be a fuel cell or a hydrogen engines. I think the structure is going to be same, and this is how it works. So I'll not go detail into each and every component because we have already only another 10 minutes left out. As I told, today we are working on machine learning models for a safety purpose. Safety in case two. One is the storage of the vehicle, and we are using the same learning models also for the combustion or a DOE, basically for the combustion optimization, monitoring the engine safety. Yeah. So what I see in future is seeing this lower powered vehicles. Initially, it may be running on battery. It can change over to hydrogen. Medium power vehicles will be hydrogen, probably CNG or a fuel cell. Bigger vehicles will be with H2Is, which is hydrogen powered internal combustion engines. Yeah, and we may be predominantly with green hydrogen. If green hydrogen cannot meet, we may be with like say gray or blue. Okay, so 10 minutes. I will skip some topics. If you have questions, probably we'll go from there. If you have 5 minutes, we'll take one particular task of machine learning. Probably I will take another 2 minutes to complete it. Yeah. So the last one. Yeah. So now, let's say we have engines. Assume it's a 4-liter engine. There is a 4-cylinder, so which means 1 liter per engine per cylinder. So you know, like any engines which we produce cannot be produced without tolerance. Yeah. So take this a particular example. For example, this engine is a 4-liter 4-cylinder, and assume that first cylinder is machined so that it's exactly 1 liter, but because of a tolerance plus or minus 0.1 liter. So assume we have a 4-cylinder 4-liter engine. So ideally it should be 1 liter out of each cylinder, but because of our today's machining process, we have like say tolerance of plus or minus 0.1 liter as a tolerance coming from honing and other process. So this is the case. So now target is that my engine should be having equal power coming out of all the cylinder, which means that if I have 100 HP, this guy has to produce 25, 25, 25, 25. But in this case, because of the engine size, probably this will produce say 25 HP, but hypothetically this may produce less than 25 HP. Let's say assume 23 HP. So like this is a practical scenario. The short question is, if I want to have a target like odd cylinder should be producing equally, I have to come out of this variations coming from engine. Let it be a diesel engine or a hydrogen engine, or future we speak hydrogen. It should not be like because of higher calorific value, one cylinder produce perfectly what is required for BMEP. Other case, other cylinder cannot produce low or high is very dangerous. The question is, how do I make all cylinder produce equal power so that engine is very stable? Probably in the query session, you can reply, but if somebody has an answer, you can tell how can I come out of this issue? Because hydrogen has 3 times a higher calorific value, which means that a small tolerance is going to be 3 times for hydrogen compared to diesel and petrol. How can we solve this? Any opinion or idea how can we come out of this issue? Okay, quickly I will cover up. So what we can do is like say we can study or take a data, sensor data from the engine, which is a wheel speed or a crankshaft sensor, a speed sensor. We can understand from the signal. We can develop a model or a learning model taking the sensor data. Based on this particular data, we can try to see which particular, based on cam and crank profile, we can see from 360 degree of rotation, which particular cylinder is producing power. If I'm going to produce 1 liter in my direct injection engine, I don't disturb this. If this particular cylinder has 0.9 liter or it's producing lower power, we can try to optimize the fuel just by the model what we have it. We don't invest, for example, a machining of all the engines. Let's say assume per year I'm producing say 2 lakh engines. I cannot invest on a costly process or a strict tolerance, which is going to be my production costly. We can take a electronic control along with the models, machine learning models. We can able to come out of this issue. Yeah. So this is where world is looking at, like say, in building or using electronics and machine learning models as a one of the use case to maintain or come out of this particular higher calorific value of the tolerance issue, because we are expert in engines. So we see like this is one of the budding area for improvements.
Sir, I am Perichiyappan consultant.
Yes, sir.
I got one question, sir. Regarding railways, they are doing a heavy duty, sir. That they are employing this geared engine or like, I mean, you have shown this 4-stroke engine like that. Anything they developed, sir. In German and all, they have made a hydrogen powered engine. But
Yes.
these engines are like this only, or any other like
It's the same
directly.
principle. It's the
Okay.
same principle. In Europe, there is a hydrogen-powered trains which is running, and it's in a pilot project. It's not a full-fledged project, but they started running it.
Okay, because ICF also going to start now.
Correct.
Intel Coach Factory. Intel Coach Factory already they have made a one coach in India.
Great.
ICF Perambur.
Yes. Okay. Reason behind this, as I told, government pushes there. So all the segments they are trying to push hydrogen as a fuel because it's technically possible. It's only a matter of development.
Okay. Thank you, sir. Thank you.
The 2 questions are in the chat box. One is amount of fuel supply can be regulated.
Okay, sir. Amount of fuel supply, as I hinted today, the fuel supply regulations are mostly coming from the electrolysis point, and it is only on a closed environment, like say government projects or a NTPC or a state governments are running it. So in that way, it is getting regulated. And now, as I hinted, AI's process has come to say that how the fuel has to be supplied and what is the safety things should be available and what is a mode and who has to and or what is a basic license fee if somebody has to do a supply chain. So this has come back, and this is still evolving because only a draft is available, but this should be, in principle, I can tell this should be more or less closer to what today we are doing for CNG. It will be coming in that same way.
Another question in the chat box is, what are the major challenges in developing the robust hydrogen refueling infrastructure?
Okay, so refueling infrastructure, the main problem is now, as I told, this particular has a 3 times higher calorific value. It cannot be handled as today as like what we are handling other refueling strategy. Time wise, as I told, probably it needs 10 minutes to fill up. So it's not a big concern like say we need a whole night charging like electric vehicles or something. So that refueling infrastructure is not a concern, but the way how they are refueling, like say safety concern, as I told, we have to have sensors mandatory, because the challenge is that this colorless, odorless gas with 3 times flame velocity will have, even as a small spark coming out, it will have an adverse effect. So that way is what I hinted. There are a lot of automotive standards CAs has come back. So if you remember, I presented some closer to 20 legislations are there. Mostly a challenge and main is the combustion and the controlling the power supply, which is coming from the tank to the engine.
So I'm Dr. S. from the Department of Mechanical Engineering. Esteemed guests, dear participants, and my fellow colleagues, it is my privilege to express our sincere gratitude to our distinguished guest speaker, Mr. Venkatesh, Manager R&D at Bosch, for delivering such an insightful and enlightening lecture on design and testing of hydrogen-powered vehicles. His expertise and passion for the subject are truly awesome. And his presentation not only opened our understandings on hydrogen technology, but also it ignited our interest towards the achievement of future sustainable transportation. Also, we are very fortunate to have had the opportunity to learn from such a renowned industry expert. His valuable insights will definitely shape our future endeavors in the field of automotive engineering. And on behalf of the School of Mechanical Engineering of B.S.Abdur Rahman, Crescent Institute of Science and Technology, Chennai, I extend our heartfelt thanks to Mr. Venkatesh once again. Thank you, sir. We hope to have the honor of hosting you again in the near future. And thank you for all the participants as well. Thank you all.